Connections among South and East Asian summer monsoon in a warming environment. Dr. Milind Mujumdar.
थैंक यू सर. नमस्कार जी. मैंने प्रिपरेशन की थी पूरा हिंदी में बोलने के लिए, लेकिन शायद हो नहीं पाएगा क्योंकि जस्ट एक दिन का समय मिला मुझे. एक दिन पहले ही ये पता चला था, लेकिन फिर भी मैं कोशिश करूंगा जहां तक मुझसे हो पाएगा. तो ये जो प्रेजेंटेशन है, ये सारा प्रेजेंटेशन बी प्रीति जो रिसर्च स्टूडेंट थी, जो हमारी कलीग हैं और इन्होंने पीएचडी किया. ये इनका पीएचडी चैप्टर है. ये जो क्लाइमेट डायनामिक्स में पेपर पब्लिश हुआ है, कृपलानी सर उनके गाइड थे और मैं सौभाग्यवश उनका को गाइड रहा हूँ. काफी हम लोगों ने इस पेपर को लिखते समय काफी कुछ सीखा इस पेपर से. सो दिस रिसेंट ट्रेंड्स एंड टेलीकनेक्शंस अमंग साउथ एंड ईस्ट एशियन समर मानसून in warming environment. I will try to cover very briefly this because all the aspects it will not be possible, and try to, for the want of time, I will just schedule it for 15 minutes. No, I will not exceed more than 10 to 15 minutes. Before I begin, let me first thank organizers and importantly our respected director, Professor Ravinandan Joya, for giving me the opportunity to present this paper. So, in the set, actually, today I just talked to Professor Shetty, his this Foundation Day lecture. He has set a very good background of for the monsoon circulation. The way he described this monsoon circulation, I really enjoyed his talk. And I will just extend few of the concepts, basic concepts, what I have learned from him. So, to begin with, what is this? How we define these classical monsoon regions. Again, this is a very classical definitions given by several scientists I have pointed out here. And the important thing is, it is the annual reversal of the large scale circulation and precipitation. That is what it defines this region, monsoon region, extending from the African continent to Asian and up to parts of Australian country. Important is the Asian monsoon region. Asian monsoon region, it is the largest one, extending from 40 degree east to 160 degree, almost 160 degree east. And among this Asian monsoon also, it has been classified in various sub-monsoon systems like South Asian monsoon system, Southeast Asian monsoon system, and then East Asian monsoon system. Under the East Asian monsoon system also Changma, Bayu, Mayu, various monsoon system. But here particularly the South China, the region of South China, what we will be focusing on the South China and the region of this Korea and Japan. There have been several studies I have listed. Maybe you may be able to read that. And we have the Indian, our all co-authors from IITM. There have been lot of study in connecting the two Asian monsoon subsystems, the South Asia and South Asian monsoon and the East Asian monsoon. Starting from Dr. S.V. Singh, Dr. Kriplani, Dr. Nityanand Singh, Dr. Ashwini Kulkarni, Dr. Krishnan, many sites we can see from our publication list. Whenever we make the presentation, we try to see IITM has really contributed a lot in understanding this, the teleconnections and this the trend among this subsystem, Asian monsoon subsystems. So, importantly, this I will begin with the description of, again, this is again just I am extending the rainfall distribution, again what Professor Shetty had shown, I am extending it, expanding it into the regions of East Asian and Southeast Asian monsoon. So the region, you can see here the rainfall, the large amount of rainfall you can see over the Western Ghat plains of, again the Indo-Gangetic plains, the region of monsoon trough region. And then this hilly regions of Myanmar and this Myanmar coast, then Southeast Asia, regions of Southeast Asia, again the South China, and the regions of, again as I showed, I told about this Korea, peninsular regions of Korea and Japan. So this This is interestingly, you can see the variability also. If you see the variability, again over this, the regions where this rainfall, heavy rainfall is there, or the precipitation is large amount of rainfall occurs, the regions of this variation is also large over the same region. If you see the west, again the same region, west coast extending in the this Indo-Gangetic plain, extending into Myanmar coast, and the Southeast Asia, the South East Asia, the South China, and the regions of this, again the Korea and Japan. So interestingly, I mean, how these two monsoons are distinct. I mean, the distinction draws. This is, I mean, the nature of these two monsoons, two subsystems. That is, one is the South Asian system, and another one is the Southeast Asian system. What we see here. Of course, the South Asian system is of tropical nature, very well described by Sikka and Gadgil. Again, I mean, I take proud of this IITM contribution and describing this, the nature of this. And whereas this East Asian, monsoon, subsystem monsoon is characterized, it is of hybrid nature. Again, the interaction, again the complex interaction between monsoonal current and mid latitude. You can see that. And interesting. I mean, that is what I mean referred as a subtropical frontal zone. Ding and Sikka and Ding 2007. There are several studies on this. So this is the basic difference. Extending this is mostly extending up to 30 degree north, just well below 30 degree south of 30 degree north, while it extends north of 30 degree north, and of having this subtropical frontal, this hybrid nature. Again, the large scale circulation, as far as the large scale circulation, just I am giving the background and then I will come to the point what we want to describe on this long term trend among these two monsoon seasons. So how these two monsoon seasons are influenced by the large scale circulation. Again, as the monsoon, as I told, I mean, it extends from 40 degree east to 160 degree east. You can see that the South Asian monsoon, particularly the South Asian monsoon strong influence of southwesterly, very well described in this today's lecture by Professor Shetty. And then monsoon trough, you can see this easterlies. Again, these are the streamlines. I have plotted the streamlines, and these contours are the MSLP. The streamlines, again, the shading of the streamlines depict its magnitude. So you can see these streamlines are the wind circulation, 850 millibar wind circulation, and this again these contours are the MSLP. You can see the structure of this subtropical high, and the monsoon trough also. You can see this monsoon trough. Here the winds are reversal of the winds easterly to the north of monsoon trough and westerly to the south of monsoon trough. You can see very clearly over this region. Interestingly, this North Pacific subtropical high, this belt actually, the transition of this belt convergence zone, which has a southeasterly as well as this this easterly also influence. This is very important, and I will focus on this more on this. Then the upper tropospheric, as far as the upper tropospheric feature is concerned, this is the 200 HP. Again, these streamlines are the 200 HPA circulation, and what we have plotted is the shaded is the OLR, where the lower values of the OLR is inferred as a deeper convection, and high values are it is the dry regions. So you can see here the large scale Tibetan cyclonic structure, easterly jet, and then mid-Pacific troughs also you can see over this region. So this is the upper tropospheric circulation, and which is superimposed on the convective regions, highly convective regions of Bay of Bengal, and the regions of this west coast also you can see extending over this Myanmar coast, and extending into South China Sea and east of Philippines. So the first and foremost is this southwesterly flow that influences, that has a dominant influence over this South Asian monsoon. Again, this was well described by Saha, Bawdekar 1977 and Bawdekar and Khadkar 1982. Interestingly, this region, the East Asian monsoon, has a more dominant influence of subtropical high, But also it has the influence of this southwesterly flow which crosses this southeast monsoon region and reaches to this South China Sea and further north. This was also well described. This the influence over this, which is influenced this East Asian monsoon, which is influenced by North Pacific subtropical high by Murakami, Niyomi 1999, and Lee and Kawaete. The interesting part here is the Tibetan anticyclone. Again, it has a interface. It has a dominant interface. You can see the eastern flank of it has a dominant interface between the which forms the interface between the South Asian and East Asian monsoon. So this has also its own importance. So having told this, now we'll go to the trends. What we found that this is a linear trend. The slopes you can say over the region, and interestingly what you see over this South Asian region and the commonality between the South Asian region and the East Asian region, the north one you can see the north is almost all dry, and it's the southern part is mostly the wet. So same structure you see here. Most of the northern regions over this eastern East Asia is dry, while this one remains this is wet. So the excess and the below normal rainfall, the trend what it depicts over this southern part, southern part of this region, particularly over the west coast, South China, the peninsular, Korea and Japan. You can see the regions of this exhibit the increase of rainfall trends, and these dots are this defines the statistical significance over this region. So you can see the trends, how the trends are, the spatial distribution of the trends over the South Asian region as well as the East Asian region. If you see, this is another interesting part. To cut the long story short, just I will come to this long-term trends over this, and particularly the trends are taken 1970 to 2014. I mean, taking into consideration the satellite era data sets. And this has been again it has been verified with various other reanalysis products and whatever data sets were available. So you see, if the long-term trend over this SST trend, if you see, this is the warming SST trend over the West Indian Ocean, particularly the West Indian Ocean, the regions of this equatorial Indian Ocean, and the West Pacific Ocean. Almost, it coincides with the structure of the La Nina. This structure, what you see here. Interestingly, this warming of how this the long-term trend or the warming over this West Indian Ocean, how it influences the tele-connection and the trends over this region, or the rainfall distribution over South and East Asian region, that we'll see. But see as compared to the East, the West is warmer. Again here if you see the Bay of Bengal and Arabian Sea, the Arabian Sea or the West Indian Ocean depict the more warming, stronger warming as compared to this Bay of Bengal. The mean sea level pressure, again the long-term trend, what we depict here, how the long-term trends are seen in the mean sea level pressure, you can see very clearly. Again the dots, what you see, the dots again statistical significance, and the shading also you can see the high pressure, the positive. Of course, it is what you see this trend, these values for per 45 years. This is for the 45 years. What you see here, this millibar or HPA, whatever. You can see here. So this is again you can see very distinctly for the South Asia. We can see that the trough. The structure also, what we have drawn the structure with in reference to the 1970s, the initial year. So the structure also, it is confined to the more northwest as compared to what we have seen the 1970. This black one is the 1970 curve, and this red one is the trend, the inference derived from the trend over 45 years. So you can see it is more confined to the northwest region, and the region here also you can see what you see here is the high pressures prevailing over the Pacific region, northwest Pacific region, and the low pressures over this region. And the shifting, the subtropical high, the shift also, you can see the shift here is almost 4 to 5 degree, while the shift is 2 to 3 degree. Of course, this has been well studied and well described by Zhou et al. 2019. I'll come in a minute. I mean, we have also done the study, separate study, different study. But interestingly, the weakening of the large-scale circulation and the weakening of the monsoon trough, again which confines to the northwest region, and the westward shift. That is a important thing. I mean, important aspects I want to bring through this figure. How does this long-term? How does it? These trends are. How does this trends look like for this? If you see the wind at 850 HPA, again this is for the 45 years. You see the interesting part is you tend to see here the northerlies, mostly the meridional, the zonal component. What you see, the zonal component is reduces as compared to its meridional component, and you see the northern southerly. These are different. This is the just 45 years. Just 45 years. These are the trends for the 45 years. Separate U and V, and the speed is, that is the speed wherever it is statistical significant, that is marked by blue color, blue shading. Other things are which are not marked by blue, they are not statistically significant. So the main thing is you can see the region over the Bay of Bengal also. Is, of course, this is the weaker, but it is the anticyclonic circulation. You can see the northerly intrusion, and this region again see the kind of cyclonic structure, and the Madagascar high also. You can see this the westward shift of again the high pressure, and you see the which is to the west of it, and as compared to its eastern counterpart, and the shift also you can see for the 45 years, which tend to maybe strengthen this cross equatorial flow, but again maybe it may be leading to this, it may be again contributing to this region. So how, this is what is studied using different, this has been verified using various techniques and statistical analysis and reanalysis data products. But interesting part is, what could you see this in reality? What in the perspective of this so we found that Indus is flooding over the Indus basin during 2010. So this, I will not get into more details of that flood during 2010 flood, and which was, again I will show you, which has followed by 2011 over the same region, northwest Indo-Pak region. But you can see what interestingly, it has followed to 2014-15 also, those floods you have seen, 11, 10, 11, 15. We did the rigorous analysis, I'll come to that. But interestingly, what you can see here is the region, the rainfall, the precipitation occurred over this region. Northwest Indo-Pak region was more than 1.5 sigma. And subsequently also we have seen almost it has increased more than 2 sigma. You can see the structure. Interestingly, over this region, again the rainfall, more rainfall over this monsoon trough region or central continental region. The rainfall has reduced, which has extended well into the southeast and South China Sea. Again, the rainfall exceed over this South China. You can see part of South China, Korea and Japan region. So this was again the 2010 was La Nina year. You can see, and lot of synoptic scale activity, surges they call synoptic scale activity took place over this region. While the Bay of Bengal was wide of any depression or significant low pressure during that 2010, having the La Nina year. Very clearly you can see which depict the structure of the La Nina equatorial region. If you see the east equatorial region, Indonesian region, you see the heavy rainfall and Central Pacific, you see the void of rainfall. So this this structure, how does this structure connected to, does it have any influence of the westward shift of large scale circulation? So we look into this mean sea level pressure, and what we saw interestingly is the subtropical high, the two structure, the subtropical high, the shift of subtropical high by 10 to 15 degree east, and then this if you see the monsoon trough also, it was also again confined to, particularly during 2010 La Nina year, it was more confined to the northwest region. So this shift was also more than 5 degree longitude. So you can see that this 2010 depicted a very clear westward shift of circulation. And then we did the UF analysis. I'll run fast now. UF analysis 2010, again it turns to be peak, and then we did the regression analysis, and we saw this structure, which is again, this was a really starting point for finding out the when Dr. Tuplani saw this picture. This was published in our 2012 paper. Preeti also was the co-author in this. And this is how we started actually looking into, he said, why don't you are restricting just to South Asian region, Northwest, Indo-Pak region, or the Indus Basin, why don't you extend it over the East Asian region and see the structure what we saw there. Again, the void of the rainfall, over the Indian subcontinent, part of the Indian subcontinent, West Indian Ocean, this Arabian Sea convection is high. Again, the Northwest region is, it depicts stronger convection. Again, this is the OLR picture, and then it extends this whole, this gets suppressed over this Bay of Bengal and extending up to South China Sea, east of Philippines. While this region, again, it gets a strong convection. So this was a really triggering point that we should look into long-term trend, and then we should, then we did, again, as I told you, this was not the only one. In Indus Basin has observed several floods during 2010. The severities differs, but 2010, 11, 12, 13, 14, and then we did several experiments to understand the this westward shift. What is that influences this westward shift? Again, the Priya, our research student, PhD student, she got this paper, also got last year award, best student paper award. So this was again, we did several experiments. This is a SST distribution during 2010. You can see very clearly the strong gradient and the warming also over the Pacific, West Pacific region, and particularly over the Arabian Sea. We had done several experiments using this high resolution LMDZ model, which has a zooming facility, and it has a good monsoon simulation, which has been very well documented in this paper. So this has a 35 kilometer resolution. This has helped us to make several experiments using this SST to find the influence of the SST. Again, I will not get into the details of this SST, but to just give the flavor of this simulation. It is almost realistic. You can see this is the observed from the reanalysis. We have again verified with the different reanalysis products, and then we found that yes, the moisture transport. You can see this moisture transport, the divergence here, particularly the divergence over this region, the convergence from the Arabian Sea. You can see the moisture transport over this region, and the deeper convection over this northwest Indo-Pak region, this Indus Basin region, and then void of convection. Again, the interesting part is the void of convection, which extends from Bay of Bengal, part of continent, extending over the South China Sea and further eastward of this Philippines region. While this region, again, you see the convection, over the part of this Korea and Japan, you see that anomalous convection over this region, and the part of this South China also you see this convection. And if you see this is reasonably captured in the simulation. Interestingly, you can see this against the control simulation. What we have found here is this is the vertical velocity. We have found the PDF of distribution. You can see as compared to the this control experiment, the real SST when it was forced, you can see it extends well. So it is able to capture that extreme event over the region. Again, we had looked how whether this CMIF change, again this these long-term trends, we are able to how they are depicted from the CMIP in the CMIP models. So what we found is, I'm just showing this XS 1.0 and this has been published recently. I mean, this is also published in this Asia Pacific Journal of Atmospheric Science. You can see here, these are the three, this curve, the shifts, the oscillation, the oscillatory behavior, what it comes out. This is the historical period, 1975 to 2005, 20. This is the near future, and this is the far future. You can see very clearly the distinction, particularly the West Pacific subtropical high. There is a westward extension, and again it is going close to the black curve. So this oscillatory behavior was depicted by this CMIP run. So the future projection also, we tend to see that it has a oscillatory behavior. Again, weakening in the near future, and then again returning to its normal position during the far future. So again, coming back to I will come back to this and then see, is it just the spatial distribution long-term trend what we have seen? What about the interdecadal or other variabilities? Yes, the monsoon, the decadal variability is superimposed on long-term trends. You can see very clearly. I will just focus on this South Asia and this Korea-Japan region. You can see that it is the opposite. They are in the opposite phase, and the decadal variability also is very, very, very coherent between these two. This South Asian and you can see part of this Southeast Asia, this East Asian monsoon region. Interestingly, we have extended this. It's not just we stopped all this thing. We have, long-term, using the long-term records, rainfall records, the tree ring and the long-term record. The tree ring is almost 523 years. You can see very clearly. Paper published by Borgaonkar. We have used this data, and we have again verified this, our hypothesis that how the long-term trend between this South Asia and East Asia, how the variation among these two regions. You can see the Korea also. Dr. Kriplani got this record. This rainfall for long-term record more than 230 years. Yes, 230 years, and you can see the opposite phase. They are in opposite phase, the decadal scale as well as the long-term also. You can see that. So I have to summarize. First and foremost is the rainfall trends. If you see, that is it has over the South and South Asian and East Asian region. If you see, again the north is exceeding, and the southward region over the south, that is north is decreasing, and the southward region is increasing. Westward shift in large scale monsoon circulation, particularly the monsoon trough over the South Asia and North Pacific subtropical high over the East Asia is seen very clearly. That is what we have seen, and the oscillation behavior in the near future and the far future. Westward shift and weakening of monsoon trough, again it can modulate moisture supply over the Indian subcontinent and influence heavy precipitation over Indus Basin. So this is the one inferences we could draw. We have studied in very detail. Again, the westward shift and intensification of this North Pacific subtropical high can strengthen the moisture transport and precipitation over East Asia. During 2015, we have published paper in Climate Dynamics about this 2015 paper. I worked with Suraj, and we have seen that yes, the asymmetry of the convective systems over this Pacific and West Pacific and East Pacific region. Then our MTech student Roja also did some analysis using this shift of the trend in large scale circulation, particularly the subtropical high, and she has also connected very well. We found the correlation between the variation in subtropical high and the monsoon rainfall over various regions of the monsoon rainfall, South Asian regions of the monsoon rainfall. Again, with the Hamza also, we have done the Cordex with using the Cordex analysis, the rainfall analysis, and we tend to see the shift of large scale shift, the influence of large scale shift in the near future and far future. So, and these are the results which are published. So this westward shift and intensification of again the North Pacific subtropical high, again it has a lot of implication on South and East Asian region, and there are coherent linkages. Again, we have seen South and East Asian precipitation on the interannual as well as the decadal time scale using the observational and paleoclimatic records also. Further research, of course, the further research is needed to understand. We are still working on these lines to understand the dynamics of tele-connections among South Asia and East Asian monsoon subsystem. Thank you.